Code Articles 300.44, 300.11, 300.12, and 300.34c may support concerns regarding the installation of a surface conduit. Article 300.44 states conductors exposed to mechanical damage shall be guarded or protected. Article 300.11 states conductors shall be supported in an approved manner. Article 300.12 states exposed non-metallic wiring shall be supported in an approved manner and shall not exceed the voltage and temperature limitations of the non-metallic cable. Article 300.34c states conductors installed in shallow chases in masonry, concrete, or tile walls shall be protected against physical damage. Exposing conduit is a serious concern. A conduit run across the top of the ground exposes the conductors to mechanical damage from foot traffic, vehicles, or other hazards. Instability of supports is another serious concern. Short pieces of strut with stakes driven into the ground may not provide adequate support for the conduit, especially in areas with high winds or other environmental factors. Protection of underground conduit is also important. Conduit buried in shallow chases in a masonry wall should be protected against physical damage, such as drilling or nailing. Alternatives to surface conduit should be considered to meet safety standards. Firstly, underground conduit should be considered. Installing the conduit underground in a trench or using direct burial cable provides better protection from mechanical damage. Secondly, running the conduit overhead on poles or other supports can eliminate tripping hazards and provide better protection from physical damage. Thirdly, using flexible or rigid conduit with armored or clad finish can provide additional protection against mechanical damage. It is important to communicate any concerns to the engineer and explain the relevant code requirements. Alternative solutions can be provided that meet the safety standards and provide a reliable and durable installation. The installation of the feeder to the disconnect requires careful consideration of the applicable electrical codes and safety standards. The proposed method of running conduit across the ground supported by strut and stakes raises concerns related to mechanical protection, support requirements, and potential hazards. Reviewing the applicable code articles and considering alternative installation methods will ensure safe and compliant installation. Article 300.44 specifically addresses the protection of conductors from physical damage. When conductors are exposed to mechanical damage, they must be adequately guarded or protected. In the context of a conduit run across the ground, this article is highly relevant. The conduit would be susceptible to damage from various sources, including foot traffic, vehicles, equipment, and environmental factors. The risk of physical damage to the conduit and the conductors within is substantial. Article 300.11 focuses on the support requirements for conductors. Conductors must be securely supported in an approved manner. The proposed method of using short pieces of strut with stakes driven into the ground may not meet the requirements for adequate support. The support system must be capable of withstanding the weight of the conduit and conductors, as well as any additional stresses imposed by wind, ice, or other environmental conditions. The stability and durability of the support system are critical for ensuring the long-term integrity of the installation. Article 300.12 applies to exposed non-metallic wiring. This article mandates that the exposed non-metallic wiring must be supported in an approved manner and must not exceed the voltage and temperature limitations of the non-metallic cable. If non-metallic conduit is used for the installation, it is important to ensure that it is properly supported and that the voltage and temperature ratings of the cable are not exceeded. The selection of appropriate materials and support methods is essential for compliance with this article. Article 300.34c addresses the protection of conductors installed in shallow chases in masonry, concrete, or tile walls. Although this article may not be directly applicable to a surface conduit run, it highlights the importance of protecting conductors from physical damage regardless of the installation method. The underlying principle of protecting conductors from damage is consistent across different installation scenarios. The concerns related to the proposed installation method include mechanical damage to the conduit and conductors, inadequate support for the conduit run, and potential safety hazards. The surface conduit is exposed to mechanical damage from various sources, including foot traffic, vehicles, equipment, and environmental factors. The conduit may be crushed, punctured, or otherwise damaged, which could compromise the integrity of the conductors and create a safety hazard. The short pieces of strut with stakes driven into the ground may not provide adequate support for the conduit, especially in areas with high winds or other environmental factors. The conduit may sag, become dislodged, or even collapse, which could create a tripping hazard or damage the conductors. The exposed conduit run creates a tripping hazard for pedestrians and a potential obstacle for vehicles and equipment. The lack of protection for the conduit and conductors increases the risk of electrical shock or fire. Several alternative installation methods can provide better protection and meet the requirements of the electrical code. Firstly, underground conduit can be considered. Installing the conduit underground in a trench or using direct burial cable provides better protection from mechanical damage. The underground installation protects the conduit from foot traffic, vehicles, and environmental factors. The depth of the trench and the type of cable used should be selected based on the specific soil conditions and the expected loads. Secondly, overhead conduit can be considered. Running the conduit overhead on poles or other supports can eliminate tripping hazards and provide better protection from physical damage. The overhead installation keeps the conduit out of reach of pedestrians and vehicles. The height of the poles and the spacing between supports should be selected based on the specific site conditions and the applicable electrical codes. Thirdly, protected conduit can be considered. Using flexible or rigid conduit with armored or clad finish can provide additional protection against mechanical damage. The armored or clad finish provides a physical barrier that protects the conduit and conductors from damage. The type of conduit selected should be based on the specific environmental conditions and the expected loads. In addition to selecting an appropriate installation method, it is important to communicate the concerns to the engineer and explain the relevant code requirements. Providing alternative solutions that meet the safety standards and provide a reliable and durable installation is essential. The communication should be documented to ensure that all parties are aware of the potential hazards and the proposed solutions. Selecting the appropriate materials is a critical step in ensuring a safe and compliant electrical installation. The choice of conduit and conductors should be based on the specific environmental conditions, the expected loads, and the applicable electrical codes. Using high-quality materials that are designed for the intended application is essential for long-term reliability and safety. The installation of the feeder to the disconnect requires careful planning and execution. It is important to involve qualified electrical professionals who have the knowledge and experience to ensure a safe and compliant installation. The electrical professionals should be familiar with the applicable electrical codes and safety standards, and they should be able to identify and mitigate potential hazards. Proper grounding and bonding are essential for ensuring electrical safety. The grounding system should be designed to provide a low impedance path for fault currents, which helps to protect against electrical shock and fire. The bonding system should be designed to connect all metal parts of the electrical system together, which helps to prevent the buildup of static electricity and reduces the risk of electrical shock. Regular inspections and maintenance are essential for ensuring the long-term reliability and safety of the electrical installation. The electrical system should be inspected regularly to identify any potential problems such as loose connections, damaged conduit, or corroded conductors. Any problems should be corrected promptly to prevent further damage or safety hazards. The electrical system should be maintained in accordance with the manufacturer's recommendations and the applicable electrical codes. The installation of the feeder to the disconnect requires a thorough understanding of the applicable electrical codes and safety standards. By carefully considering the potential hazards and implementing appropriate mitigation measures, it is possible to ensure a safe and compliant installation. Proper planning, material selection, installation practices, and maintenance are all essential for achieving this goal. It's also important to note that even seemingly minor deviations from code requirements can have significant consequences, potentially leading to equipment failure, fire hazards, or electrical shocks. Therefore, strict adherence to code specifications is not merely a matter of compliance but a fundamental aspect of ensuring safety and reliability. It is vital to conduct regular inspections and maintenance of electrical installations to identify and address potential issues before they escalate into serious problems. This proactive approach can prevent costly repairs, minimize downtime, and, most importantly, protect lives and property. Additionally, electrical systems should be designed and installed with future expandability and adaptability in mind. This foresight can facilitate future modifications and upgrades without compromising safety or performance. Communication is key throughout the entire process, from initial planning to final commissioning. Open and transparent communication among all stakeholders, including engineers, contractors, inspectors, and end users, can help to identify and resolve potential issues early on, ensuring that the installation meets all requirements and expectations. In addition to technical considerations, it is also important to consider the environmental impact of electrical installations. Choosing energy-efficient equipment and adopting sustainable practices can help to reduce energy consumption, minimize pollution, and conserve natural resources. Finally, ongoing education and training are essential for electrical professionals to stay abreast of the latest codes, technologies, and best practices. Continuous learning enables them to provide the highest quality services and ensure the safety and reliability of electrical installations.